geez, for a minute there I had it on slow-mo. Can you think of anything worse than Precal in slow motion? Ah. All right. All right, here we go. Number 5. Suppose for a minute that you don't prepare, so you randomly guess on a 10-question multiple choice quiz. Each question has 4 options. Find the probability of getting exactly 7 correct. Now, remember, how many questions does this quiz have? 10. So if you are getting 7 correct, you are getting 3 incorrect, right? So here we go. There are 10 questions, and I want to pick 7 of them to get right. So I'm going to start with 10C7. The probability of getting them right is what? What is the probability of guessing correctly? Oh, look at the question. I'm answering question 1. What's the probability I get it right? 1/4. 1/4. Aren't there 4 options for each question? Kids, sit down, look at the quiz. Question 1, I don't know, A. The probability it's A is 1/4. Some of you can relate to that. It's 1/4, right? So the probability of getting it right is 1/4. The probability of getting it wrong is 3/4. We want 7 rights and 3 wrongs. That's the setup. So I go to my calculator and I can type all that in. You can do it in parts, you can do it all together, it doesn't matter. The calculator is a wonderful thing. Sometimes on these I use decimals, like instead of 1/4, I might use 0.25. What'd you come up with? 0.003? Yes, it's that low. 0.0031 if I round it off. Now, keep in mind, that is not the percentage. That is the decimal. The percent would be 0.3%. Yeah, better study. All right, at least 9 correct. You know, what does at least 9 mean? I could get 9 correct and 1 wrong, or I could get 10 correct. It's going to be a 2-part problem. So 9 correct would be 10C9 times 1/4 to the 9th and 3/4 to the 1st. Would you agree with that? Or I could get 10 correct. So 10C10, 1/4 to the 10. If you want to add 3/4 to the 0, you absolutely can. It won't change a thing. Kind of keeps everything looking alike. If you get 10 right, obviously you're getting none wrong. I bet this is even a smaller number. Oh my gosh. I got a little itsy bitsy number, did you? Yep. I got 2.956 times 10 to the negative 5th. Wow is right.
So don't not study this.
Bingo! There it is, right there. All right. At least 1 correct.
Oh, this is more like it. 1.
Okay, so yeah, So at least one correct means 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, right? What did we just talk about though?
1 minus 1 minus.
All of them wrong, right? Oh, none right. So the easiest way to do this is to do 1 minus 0 correct. And remember, at least 1 means you get something right. So the only option that isn't included in something right is everything wrong. So I'm going to take 100% of 1 minus getting nothing right. So nothing right would be 10C0 times 1/4 to the 0, then you don't need to put that in, but I am. And then 3/4 to the 10th. Isn't that missing every single question? So here we go. 1 minus. I got 0.944.
Oh, dang. So it's a lot easier to get them all wrong.
All right, are we clear on that? All right, now we're going to do a little formula work. Remember when we who signed this?
Lady in the English building, Slow Hill building. I'm sorry.
A lady in the English
She
building.
didn't give me her name. Is her name not on there?
It's signed, but I can't read it. I can never read what people sign.
Okay. Well, I can go get it after.
Okay, now, we're going to show that this is true. All right, now, first of all, I don't know that I talked about this notation with you. This means this. These are exactly equivalent. Sometimes combinations are used so much more than permutations that sometimes they just leave the C off and write it like this. This means NCR. This means NC and minus R. Those are combination notations. Now, at first glance, fear has come into you because you're thinking, but this is easy. We need to know this formula for our quiz tomorrow. What's this formula? We talked about it already today. N factorial over N minus R factorial, R factorial. And then what's this one going to be? N factorial over N minus R. Subtract these. So N minus R factorial, N minus R factorial. Remember, when you do a combination, this goes on top, then you subtract these guys, so N minus R, and then you put this one. Now, clean this up. What is N minus the quantity N minus R? Wouldn't that be N minus N plus R? Well, what's that? That's just R. So you have N factorial over R factorial, N minus R factorial. You guys, aren't they exactly the same? They are.
I mean, I guess.
Well, let me explain it to you, Jake.
Go ahead.
If we have, let's put numbers in instead of letters.
Okay.
If we had 8C3,
Yep.
the formula for 8C3 is 8 factorial over 5 factorial, 3 factorial. I subtracted and put the second one. If I had 8C5, that would be 8 factorial over 3 factorial, 5 factorial. Aren't they exactly the same?
Yeah.
Yeah, because if there are 8 people, I think I talked about this, but I may not. If there are 8 people in the room, let's say there's 8 of you in the room, and I decide I'm gonna take 3 of you on a camping trip. So I grab these 3 and off we go. So I put those 3 in a group and I took you out. Well, when I took those 3 out of the room, grouped them together as the chosen, what about these other ones? Aren't these 5 also grouped? If there's only 8 people, when you choose 3, you've automatically chosen the other 5 as the unchosen.
Yeah.
So 8 pick 3 is the same as 8 pick 5. The number of ways to do it is the same. That's what we just proved. All right, one more. This one's a little bit more complicated, but it's still very doable. Last problem of the day. Let's hang in there. I'm gonna hand back some papers, okay? So here we go. I'm gonna write it with my combination notation, because that's what I've been doing. All right, so what's the formula for this?
That is,
N factorial,
yeah.
subtract them, and put that. That's the formula for combinations. All right, what's this one? The formula for this? That factorial. Now subtract them. So when I subtract them, what is n plus 1 minus 2? What does that simplify to? N minus 1? Guys, n plus 1 minus 2. Is that this? Is that n minus 1? So I have n minus 1 factorial, and then 2 factorial. All right, I need to add these together, but I think first I'm going to try to simplify. All right, now I know these are letters, but you get this. You can do this. What is 7 factorial? What's 7 factorial? 7 times 6. Okay, so what is n factorial? N times n minus 1. So this is going to be n minus 1, n minus 2, n minus 3, forever. That's what this is right here. I start with that number, and then I go down by ones.
Got you.
So what is this?
That's n minus 2.
N minus 2, n minus 3, dot, 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 dot.
Yeah.
And then 2 times 1. Now what happens in that mess? A whole bunch of stuff cancels, yes, Katie, and you are left with this. That's all that's left. Because everything from the n minus 2 on is going to cancel. So you have those 2, and then you're over 2. Okay, same thing with this one. What do we start with on top? N plus 1. Then we go down 1. So if you take 1 away, you're down to n. And then n minus 1, n minus 2, and so on. All right? Where do I start with that?
N plus 1.
No, where does that start? N minus 1, and then n minus 2, and so on, and then my 2 and 1. Aren't I going to lose all that? So this is what came out of the first fraction. This is what's coming out of the second fraction. And now I'm supposed to add them together and hopefully end up with that. So let's distribute. If I distribute, I'm going to get n squared minus n plus n squared plus n all over 2. These have a common denominator, so I can add them. What's that?
2n squared.
2n squared over 2, which is exactly what we wanted it to be. Now, that problem is not on your quiz tomorrow. But you do need to know your formula for the quiz tomorrow. Okay? So make sure you know how to use combinations and permutations. All right, I'm gonna stop there. 9-2 homework is gonna be due on Friday. And I am going to go ahead and